Okay, so chapter 6 is all about different ways to factor. And 6.2 is factoring by grouping. So when you factor by grouping, typically you're going to have a polynomial that has 4 parts to it. You could have a polynomial that's bigger than that, but I actually did all of the homework for 6.2 today, and all of them have 4 parts, meaning it's a polynomial that has like an x to the third, an x squared, an x, and then a constant term is basically how these are all break down. And literally, this is the notes for the day, and we work a whole bunch of examples. The main goal and what you're going to do when you factor by grouping is you're kind of pairing up. If there's 4 different terms in a polynomial, then you're going to pair up the first 2, pair up the second 2. Sometimes you do have to do some reordering to pair those up, but you're going to pair them in groups of 2. And then you're asking yourself, what does this pair have in common? What can I pull out? Basically, when you factor by grouping, you're doing the reverse of your distributive property, where you're going to be pulling something out, and then hopefully what happens is in this first pair and in the second pair, what's inside the parentheses is exactly the same. So let's do an example. It'll make more sense. Lots of examples today. X squared plus 3x plus 4x. That's, okay, yep, that's how this one is. This one's a weird one. This one I say is a weird one because if you look at those middle 2 terms, the 3x and the 4x, generally what we would decide to do is we'd combine those because those are like terms. But what they're trying to show you is you can actually separate out the middle term of a trinomial, in this case, and factor by grouping. I would say after 6.3, you will probably never choose that method, but that is always a great backup method. This is the only one that we will be doing that starts with an x squared like this, because this is kind of a different one to do. But in general, regardless of what it looks like, what we're going to be doing is we're going to be looking at these different groupings. The first 2 terms and the second 2 terms. And when I look at those first 2 terms, I have an x squared and a 3x. And so I'm asking myself, what do those 2 terms have in common? What could I pull out? An x. Yeah, they both have an x, don't they? So if I pull an x out, that's going to leave me with an x plus 3. And here's how you check. You redistribute and make sure you can get right back up here. If I distribute my x, I do get right back up here, so I've done that correctly. You can automatically check yourself. And then you go to your second pairing. I have a 4x plus 12. What do these have in common? Yeah, 4. I can pull a 4 out, and again, that would leave me with what on the inside? An x plus 3. This is what my star note up here means. You want the same thing inside of your parentheses. So when you've pulled out what they have in common, you want the same thing inside the parentheses. Because now we've gone from 4 terms to 2 terms. And what we're going to do is we're going to pull out what these 2 terms have in common, just like we just did. So if I look at this first term and I look at this second term, what do they have in common? Yeah, the parenthesis. That's why we want them to match. Because I can pull that parenthesis out front, the x plus 3, and what's left over from my second parenthesis is whatever was in front, the x plus 4. This is our final answer. Nowhere in 6.2 will you be asked to solve. We are not setting these equal to 0. We are not finding out what x is. We are not solving. All we are doing is factoring completely. Factoring until we cannot factor anymore. Did they have something like that? Yeah. You're going to see some that repeat or come up in multiple different sections because you can approach them from different ways. So, all right, let's try another one. Let's try one that actually looks like just like it fell off your homework. 2x to the third plus 4x squared plus 3x plus 6. This one is more traditional to what you're going to see actually on the homework and the quiz, because if you'll notice, all of our terms are different. We have an x to the third term, an x squared term, an x, and then a constant term. So they're all a little bit different. But we're going to do the process exactly the same way. We look at these first two terms and we say, okay, what do they have in common? 2x to the second. Yeah, because this one even has an x to the second in there as well. So I can pull out a 2x to the second power, which would leave me with an x plus 2 inside my parenthesis. And again, I can check that by redistributing it and making sure I get back up to the top. Then I'm going to look at my next pairing, my 3x plus 6, and I'm going to ask, what can I pull out of that one? A 3. And that'll leave me with an x plus 2 inside. So let's say by chance, because I heard some people saying a 2x over here, and they didn't see that there was actually a 2x squared. That's fine. If you pulled that out first, you would have been left with an x squared plus x in here, or 2x in here. And you would notice that those wouldn't match at that point. And so then you could ask yourself, is there anything else I could pull out? And you would see that you have another x you could pull out at that point, because these have to be the same. So you just keep pulling stuff out until you can't anymore. Now this is just like up here. I have two terms, and both of these terms have an x plus 2. So I'm going to pull that out front. And what I put in my second parenthesis is whatever was out in front of my parentheses anyways. The 2x squared plus 3. And that's it. I can't factor that any further. I'm not solving. I'm not figuring out what x is. This is it. Questions? We're going to do more. So we're going to see how this works. I'd say the first, actually B and C, are the ones that are pretty much identical to your homework, because I worked all of them. The ones after C are good practice. Oh, this one's another one where we split a trinomial up. But no matter if you start with an x to the third term or you start with an x squared term, the big thing you want to try and do is make sure you have your polynomial written in descending order, meaning the term with the biggest power goes first, then the next term, then the next term, and then the next term. And that's how this one's laid out too. We have an x squared, then an x, and a constant. All but 2, I believe, of your homework are already laid out in this really nice format for you. Okay, we're going to do our groupings. In this first grouping, the x squared minus 3x, what do they have in common that we can pull out? An x, which will leave me with an x minus 3. Now, what about here? What does an x and a minus 3 have? Or do they have anything? They don't really have anything. And if you notice, look, what we just found inside my parentheses is actually what we have already over here. So what we're going to pull out, and I use quotation marks for this, is we're going to pull out a 1. Because when we multiply by 1, does it change anything? Nope. Sure doesn't. But the reason why I want to do that is because I want to have this x minus 3 written inside the parentheses. So that in the next step, when I pull my parentheses to the front, I don't forget that I actually have a placeholder here. I'll have that plus 1. I know you have at least 2 problems on your homework that are similar to this. So if they don't share anything in common, you can pull out either a plus or minus 1, whichever one you're needing, in order to get the parentheses to match. on the inside. Any questions on these first three before we make it a little bit more fun? Yes?
I don't understand the last two steps. Where you go from x point to x that.
Okay. That is totally fine. So what I'm doing is when I have it written like this, I have this term right here, and I have this term right here. So I have two terms now. Do you get that? Okay. So then I'm looking at these two terms, and I'm asking myself, is there anything in this first term that's the same as the second term that I can pull out? And the answer should be always whatever's in the parentheses. If I've done my groupings right, I should be able to pull out this whole parenthesis. And so I'm pulling the whole parenthesis out front, just like I did in this step where I pulled the x out front. But when I take away this parenthesis, all I'm left with is x. And then if I take this parenthesis, all I'm left with is the plus 1. Does that make more sense? Okay. Thank you for asking for clarification, because you probably weren't the only one that needed it. Just the only one brave enough to say anything. I'm really not that scary, guys, I promise. I know it's early, though, and math can be intimidating. All right, let's look at one where we have more than one variable going on. Even if we have multiple variables at play in our polynomial, we can still factor this by grouping. Sometimes you'll need to regroup, but like I said, almost all of your problems, they're already grouped nice for you to where you can look at the first two terms and the second two terms and work it from there. So I have 2xy plus 4 is my first pairing. So what do these two terms have in common that I can pull out? A 2y. And if I pull out a 2y out of this first term, the only thing I'm left with is an x. And the only thing I'm left with in my second term would be a 2. And again, I can always check by redistributing and making sure that this is accurate, that this works. Then I'm going to look at my second pairing. 3x plus 6. What does this have in common? What can I pull out? A 3. And if I pull out a 3, that's going to leave me with an x plus 2, which is good because that's what I have in the beginning. Now I have my two terms, and they both have an x plus 2 parenthesis. So I'm going to pull that x plus 2 parenthesis out front. And when I do, you can even mark them out if you want. Look what's left over. We have a 2y plus 3. When you get down to any of these answers, notice we have a binomial, something that has two parts, times a binomial, something that has two parts. We can always check our work by foiling this if we really wanted to. I could first, outer, inner, last any of these and make sure that I get what I started with. Which is always a safe bet if maybe you do the homework, you do the first problem, and you don't have the right answer. Foil first before you just erase everything and see what happened. Where did it go wrong? Because that might help you to identify what it is you need to fix. Any questions on that one? Yes?
How did taking 3 out of the 6 give you the 2?
3 times 2 is 6.
Oh, okay, so it's not subtracting.
Nope, it's not subtracting, it is distributing, and when we distribute, we are multiplying. Yeah, that can get a little bit confusing because unfortunately 4 minus 2 is 2, but 4 divided by 2 is also 2. A little bit deceptive there. Other questions? We've got 2 more. And these last 2 are the most interesting. All right, we've got 15x to the 4th. minus 15x to the third y plus 5x squared y minus 5xy squared. You will not see one like E on the 6.2 homework, but one of the processes we're going to use on this one is very helpful for the 6.3 stuff that we will cover next time, which is why I leave it in the notes, because this chapter especially builds on itself very, very much. Now, all of these problems that we've done thus far, we've paired them up and pulled things out. But sometimes it's better to start by looking to see if there's anything at all that you can pull out of everything before you even get started. Because that will actually simplify the process later on down the road for you if there is something that, say, all four terms have in common. Yeah, they all got a 5x, don't they? So let's pull that out of absolutely everything before we actually start grouping. So we pull a 5x out front. We're going to do a big parenthesis. That would leave us with a 3x to the third minus 3x squared y. So what I'm doing is I'm thinking about what times what would give me 15, and then I'm subtracting my exponents by 1 because I pulled one of my x's out. Now, I don't have a 5 if I pull it out, and I'll only have one x and y left here. Minus, I pulled my 5x, so that'll just leave me with a y squared in that last term. So if they have something everything shares, pull that out first. And that's different than what we've seen on their other ones. So now this 5x is kind of going to hang out here on the outside for the rest of the problem. We will never redistribute it. It's just going to stay out there. Because now we're going to look at this and solve it just like we have our other ones, where we're going to group them. I'm going to look at this first one, and then I'm going to look at this second one. So I still got my 5x living out here, big set of parentheses. And then I have 3x to the third minus 3x squared y. What do these two terms have in common? 3x squared. Bless you. Which leaves me with just an x minus a y. So let's hope whatever we pull out in our next one, we can also get an x minus y. What does an xy minus y squared have in common? Yeah, they got a y in common. Let's pull one of those out. That will leave me with an x minus y, which is just what we were hoping for. Now, this in here is the same as we've always done it. We just have this extra little 5x out here. The two terms inside this big parenthesis, we have this one with the 3x squared times the x minus y, and then we have our y times the x minus y. So I can still pull the x minus y out of those two terms, leaving me with a 3x squared plus y. And I can drop the big set of parentheses at that point because everything is being multiplied together. The 5x is multiplying against the x minus y, which is multiplying against the 3x squared plus y. And I could do the FOIL method to actually check this. I could FOIL this right in here, and then I could multiply whatever I got by 5x, and I'll end up right back up here. It really does work. It checks out. So what you do is you ask, is there anything all four terms have that I can pull out? And once you've done that, you just start with a slightly simpler problem like we've had up here, and you work this no differently than you have anything else. It's just you remember to put whatever you pulled out front. Again, we are not solving. This is it. Now, if you had not pulled out anything at the beginning, would you still get the same answer? Yes, if you recognized as you worked through it that there's other things you can pull out. I can work this one again if you would like to see what happens if we don't pull anything out to get started. Is that something you would like to see? Not really. Okay. If anybody wants to stay around and after wants to see that, I have no problem showing that. If you do the pull out first out of all four, that is helpful in the beginning. Okay, we're going to do one more. Works exactly the same way as this one. That way we can kind of see how this plays out. Again, just to get a little bit extra practice. Because doing something once doesn't really teach us anything. It just shows us. And then the second time we run through it actually is when we start grasping it a little bit better. So we're going to do 12n to the fourth minus 30n to the third t minus 4n squared t plus 10nt squared. And pay attention to the variables that Pearson gives you. If they give you an equation with q's in it, then your answer has to be in q's. I know this morning there was one that had p's in it, and I typed it in with x's, and I'm like, I know that's right. And then I noticed I flipped my variable. Because in general, we usually go back to x's. That's what we're kind of trained to do. But if they give it to you with n's and t's, your answer has to be in n's and t's. So again, I would look overall and say, is there anything that all four of these terms has in common? They all have a 2 because they're all even. Okay. Are there any variables that they all share? They've all got an n. So I'm going to pull out a 2n. And when I do that, that'll leave me with a 6n to the third minus 15n squared t minus 2nt plus 5t squared. You can check it by distributing and making sure we get back up to the top. So now that 2n is going to live outside there, we're going to kind of forget about him, but not so much that we don't type him in at the end. But then we're going to do our pairings inside. So we've got our 2n outside the big set of purple parentheses. And then we're going to look, okay, we've got a 6n to the third minus 15n squared t. What do these have in common? Yeah, they've got a 3. And then n to the third, n squared, so n squared. 3 times 2 would give me 6. N squared times n would give me n to the third minus 5t. So now I'm looking at negative 2nt plus 5t squared. Well, the 2 and the 5 have nothing in common because they're both prime. 5's odd. So do they have anything in common that we can pull out at all? They have a t. So here's the question that's a little different than we've seen in any of the others. If I pull out just a t, that's going to leave me with a negative 2n plus 5t inside. Is that what's in here? No. So let's pull out a negative t. If I pull out a negative t, then it's not negative 2 in here. It's going to be a positive 2. And then it'll be a negative here because negative times positive would give me a negative. Because remember, our whole goal is what's inside our parentheses has to match. If we pull out a positive t, what's inside here does not match. So all the other problems we were able to pull out positives, but sometimes you have to pull out a negative. And that's okay as well. Nothing changes as long as you're careful about your signs.
Like So how you get the negative?
Because let me do a side note down here at the bottom. Because we're looking at this. We're looking at negative 2nt plus 5t squared, right? Because we're looking at the second term. So if I pull out just a t, that's going to leave me with a negative 2n plus 5t, right? That doesn't match. And we need it to match on the inside. And what's wrong with it right now is our signs are backwards. We have a negative 2 on the n, and we have a positive 5 on the t. So if we take out a negative, that'll switch all those signs. Does that make sense? Okay. So I've got my 2n out here. Because I pulled out that negative, what's inside of my parentheses matches. So I'm pulling that out to where I have 2n minus 5t. And again, feel free to mark those out if that helps you. Mark them out, because then what's remaining in front is what goes in our next set of parentheses, the 3n squared minus t. And all of that is our answer. We're not solving for n, we're not solving for t. And in my handwritten notes, if you look, I didn't write my t. Right here. So, typos happen. Are there any questions on what we did here?